All righty, I'm going to go ahead and get started. Today we are going to do 7.2 and 7.3. So all of this will be in your week, what are we on? 13 folder now. What 7.2 is on is multiplying and dividing rational expressions. And again, rational expressions is just a fancy way to say fraction. Now, before we get into the 7.2 work, let's go over a little bit of what we did in 7.1 because it's very, very similar. We need to look at two different types of rational expressions. Let's see if we have a rational expression like this. So here, first thing we're looking for is any kind of factoring that would need to be done. So on this one, since there is no factoring that needs to be done, like trinomials or difference of squares or greatest common factor, you're going to go simply to reduce or simplify this fraction. So remember how to do this part. We have 36 over 42. Remember, you can use math inner to reduce that fraction for you by simply typing in 36 divided by 42. So 36, then you're divided by 42. Hit enter, get your decimal, and remember with your decimal, you're going to math enter that to see that that part is going to reduce to 6 over 7. Now, once you do that, you're doing the x part of this. So remember, when you are dividing or simplifying, you're going to do the top exponent minus the bottom exponent. So I have x to the 5th over x to the 3rd. So that'll cancel and leave me with x to the 2nd. So let's see what is left in the numerator. 6x to the 2nd over what's left in your denominator, this 7. So there was that kind. Now, we also had some where we did have to factor. Oh, wait. So x squared minus 25 over 7x minus 35. So when we had problems like this that had some factoring to do, you have to do that first. So looking at your numerator, what kind of factoring would happen here? Let's see, there's two terms. I do look for something in common to pull out. It's just that there's not anything in common with x squared and 25. But they both are perfect squares with a minus in the middle. So this up here, I can factor as a difference of perfect squares. So I'm going to rewrite this fraction down here, but I'm going to write the top and the bottom in its factored form. So let's see how you get x squared minus 25. Well, how do you get x squared? X and x. 25 is 5 times 5, 1 plus 1 minus. So there's the top. Now let's try this bottom. Again, I have two terms, but I am going to look for something in common. What does go into 7 and also into 35? 7 goes into both of these. So I'm going to pull out that 7 and then put in parentheses what is left. How do you find out what is left from pulling out this 7? You divide what you pulled that 7 out of, divide it by 7. So if I pulled the 7 out of here, I'm just left with the x minus, if I divide this by 7, 35 divided by 7 gives me 5. So there's the bottom in its factored form. So now I see that the top and the bottom do have this common factor that I can cancel or turn into ones. So let's see what is left in the top. All that's left in the top is the x plus 5. And what's left in the bottom? Just that 7. So let's keep those two kinds in mind when we're doing this multiplication and division. So let's see. Now moving into the 7.2 work. Let's see what we have for a problem like number 1. We have 81 b to the 7th over 147 b to the 8th times 14 b to the 8th over b to the 5th. So what I am going to do first is look at each of these 4 spots to see, is there any factoring that needs to be done in any of those 4 spots? Well, I don't see any kind of factoring how we think of it, because there's no more than one term in each spot, right? If I'm going to factor, I'm going to have at least 2 terms, factoring how we think of it. So there's none of these things have any factoring to do, which means I'm going to go ahead and multiply, because that's what kind of problem it is multiplication. When you're multiplying, you multiply straight across in the top and straight across in the bottom. So let's see, the first thing I have is 81 times 14. So just in your calculator, I'm not going to do that in my head. 81 times 14 gives me 1,134. Now, I still have the v to the 7th times v to the 8th. Remember that rule. When you're multiplying the same bases, you're going to add their exponents. So if I add these exponents together, I'm going to get b to the 15th. So that takes care of my top. Over. Do the same thing in your bottom. You have 147 b to the 8th times b to the 5th. So let's see, if I add those exponents, I'm going to have 147 b to the 13th. Now I need to see if this fraction will simplify. I know I can do some stuff with my b's. I'm going to subtract those exponents. But let's see if 1,134 over 147 will simplify too. So let's just clear out our calculator, and that's what you're going to type in. 1134 divided by 147. Enter. Math, enter that. So let's see, what does that reduce to? 54 over 7. So it does reduce. So this is going to turn into 54 over 7. Subtract your exponents. So I have b to the 15th over b to the 13th, which gives me b squared. So once you've done all the simplifying, your answer is simply just what is left in the top over what is left in the bottom. So let's see. In the top, I have 54 b squared. Over in the bottom, I've got 7. Okay? All right, looking at one like number 2, we have 2 times d plus e over 5 times 50 over 10 times d plus e squared. Now, when I am doing problems like this, the first thing I'm going to do is, it's already factored for me, right? This 2 is already pulled out. There's not any factoring I can do in either of these spots. What I kind of want to see, though, is this d plus e squared. I'm actually going to want to see it as d plus e, right? Times itself. So let's see. I'm just going to rewrite this whole thing. Instead of writing d plus e squared, I'm going to write it out. D plus e. So let's keep everything else the same. So 2 times d plus e over 5 times 50 times 10, or excuse me, 50 over 10. And here's what I'm talking about. Changing that d plus e squared to d plus e times itself. So now, what you're thinking of is, think about this whole thing as one big fraction. I can do any canceling of parentheses. I'm not going to try. You can do some reducing, like with that 50 over 10, or that 50 over 5, or 2 over 10. But I'm not going to do that part until the very end, so I don't get all messy and lose stuff. All I'm going to cancel before I do my multiplication is any parentheses that are the same in the top and the bottom. So let's see, this d plus e right here can cancel one of these. So that's going to go away. So it only cancels one of them. Can't cancel both of them unless you have 2 of them up here too. So what you're going to do after you cancel any parentheses that you can that are the same in the top and the bottom, then you're going to multiply. So let's see, what do you have left up top? I've got 2 times 50, so that gives me 100, over, what do you have in the bottom? 5 times 10, which is 50, and I still have this d plus e, so I've got to write that. So again, this 5 times 10, which gives me 50, and then I still have the d plus e. So now you're just looking to reduce any of the number part that you can. So let's see, this 100 over 50, what does that give you? 100 divided by 50 gives you 2. So let's see, this right here turns into 2, or you can think of it as 2 over 1. So let's see, what is left up top? Just your 2. Over what is left in the bottom? D plus E. There you have it. All right, number 3, you've got x plus y squared over 2 times 60 over 5 times x plus y. So let's see what we have here. Again, I see this, another one squared. So when I see it squared, I like to just write it out so I can see exactly what I'm canceling in the top and the bottom. That's one way. That's how I like to do it because it seems more clear to me. Or you could say there's 2 of these x plus y's up top and just one of them in the bottom. So if you wanted to subtract your exponents, you would have what? You would have 1 of the x plus y's left in the top. So that's the other way you could think about it. So I'm going to rewrite it with this x plus y times itself. Still over 2, still times 60 over 5 times x plus y. So all I did from this step to this step is rewrite x plus y out twice. So let's see, now I can see that this x plus y can cancel this x plus y. And they're not just going away, disappearing. They're turning into 1. Because what makes a 1? Anything over itself. Well, I've got x plus y over itself, which just turns into 1. So now I don't see any more parentheses that I can cancel. So I'm going to multiply what is left. So let's see, what do you have left up top? You've got x plus y times 60. So you could either write it x plus y 60, or you could write it 60 times x plus y over, what do you have left in the bottom? All I have left in the bottom is 2 times 5, which is 10. So what's C? What is 60 divided by 10? Well, 60 divided by 10 gives me 6, or in other words, 6 over 1, which means I don't even need to write this denominator anymore, right? If it's over 1, you don't need to write a denominator that is 1, because 6 over 1 is the same exact thing as just saying 6. So let's see, what is left in the top? 6 and x plus y. And again, the bottom is just a 1, so you don't even need to write it. So 6 over x, oh, excuse me, saying it wrong. 6 times x plus y is what is left. Okay, number 4 is a division problem. Now, division, the definition of division is to multiply by the reciprocal, which, what does the reciprocal mean? It means you're going to flip that second fraction, and then it turns into multiply, exactly like what we have been doing already. So they're just adding a step at the beginning of this to flip the second fraction and turn it into multiplication. So let's see, I have got 9x to the 4th over 3x to the 5th divided by 3x to the 7th over 5x to the 8th. Again, if it's division, you're going to change this sign to multiplication and turn upside down this second fraction. So let's write it like that. So I have 9x to the 4th over 3x to the 5th times, this goes in the top now, so 5x to the 8th over 3x to the 7th. So let's see, are there any parentheses to cancel? There's not any parentheses at all. So no parentheses to cancel. So I'm just going to go multiply straight across on the top and the bottom. So let's see, up top, I've got 9x to the 4th times 5x to the 8th. So when I multiply, I'll multiply the 9 times 5, which will give me 45. X to the 4th times x to the 8th. I'm going to add those exponents together. So that'll give me x to the 12th. Do the same thing in the bottom. So now I've got 3x to the 5th times 3x to the 7th, which will give me 9x Again, add your exponents. 5 and 7 gives me 12. So let's see. I'll do the simplifying now. So 45 divided by 9 gives me 5 over 1. What happens to your x's? What do you get when you subtract these exponents? You get 0, which means your x's completely cancel or turn into 1s. So what's the only thing that is left in the top? This 5. What's left in the bottom? You do have 1, but what is 5 over 1? It is just simply 5. All right, moving along. Number 5, you've got 4t to the 5th over 2t to the 6th divided by 2t in parentheses to the 3rd power over -6. So it's division. So the first thing I'm going to do is change this symbol to multiplication and turn that fraction upside down. So let's see, I've got 4t to the 5th over 2t to the 6th times the -6 will go up top. Now, this is going to go in the bottom. I've got 2t to the 3rd. Let's think about what that means. That means the 2 and the t are both being raised to the 3rd power, which means both of those things need to multiply times themselves 3 times. So let's see, what is 2 times itself 3 times? Let's see, 2 times 2 is 4, times 2 again would give me 8. So 2 to the 3rd gives me 8. T to the 3rd is t to the 3rd. So all I did when I put this in the bottom, since it flipped to the bottom, is I went ahead and did this 2t to the 3rd. I did that work. 2 to the 3rd, t to the 3rd. Now, I don't see any parentheses to cancel, so I'm going to go ahead and multiply straight across in the top, straight across in the bottom. So let's see, I've got 4t to the 5th times -6. So 4 times -6 gives me -24. I don't have any more t over here, so I just have t to the 5th over 2t to the 6th times 8t to the 3rd. So let's see, 2 times 8 gives me 16. T to the 6th times t to the 3rd gives me t, add your exponents to get t to the 9th. Reduce this part of your fraction. So let's see, I have -24 divided by 16. There's your fraction, your decimal math. Enter it to see that's going to reduce to -3 over 2. So -3 over 2. Now, be careful with these exponents. If you do the top exponent minus the bottom exponent, 5 minus 9, it's going to give you -4. That should trigger and say, oh, wait, my t's need to go to the other side of the fraction bar since my exponent ended up negative. Or you could think, well, there's 5 here and 9 here, which means if I cancel 5 of these with 5 of these, I still have t to the 4th left over in the bottom. So let's see, up top, I've got, all I have left up top is that -3 over what's left in the bottom, 2t to the 4th. Okay, moving right along. Number 6, I have 8 over x minus 5 divided by 40 over 2x minus 10. Okay, first of all, it's division, which means my first step is to change that to multiplication and flip this fraction. So I have 8 over x minus 5, change division to multiplication, put the bottom into the top. So 2x minus 10 over 40. Now, something new that we haven't seen yet. So this right here, what I'm looking at are these two spots, because I'm looking at them because I'm thinking, since each of these spots has more than one term, there's 2 terms here, and there's 2 terms in that one, that's something we haven't seen yet. That says I may have to do some factoring before I can do anything else. So let's see, down here, there's only 2 terms, so I'm looking for something in common. There's nothing in common with x and 5, and it's not a difference of squares, right? Neither one of these terms are perfect squares. So there's not anything I can do to factor right here. But look at this one. There's 2 terms. Is there something in common with 2 and 10? In other words, is there a number that goes into both of them? And there is. The number 2 goes into 2 and 10. So you've got to factor that out first. So what we're going to do is just rewrite this one, because remember, there wasn't anything we could do to this fraction. So we still have 8 over x minus 5, still times, but like we said, here we can pull out a 2, since there was a 2 in common, so which means I need to divide both of these by that 2 that I just pulled out. So if I pulled a 2 out of this term right here, what's the only thing that's left? Just the x. And remember, you put what's left in parentheses. So x minus, what's 10 divided by 2? 5. Close my parentheses. I can't do anything with the 40, so I'll just bring it down. Now, look what you got. You got an x minus 5 in the top and an x minus 5 in the bottom, which means they cancel or turn into a 1. Once you've canceled any of the parentheses, you have to think about that in parentheses since it canceled that, multiply what is left over. 8 times 2 gives me 16. 1 times 40 gives me 40. Then math, enter that fraction. So let's see, 16 divided by 40, 0.4. Math, enter to reduce that to 2/5. Ta-da. Okay, let's look at the next one. Number 7. I've got x minus 6 squared over 8x divided by x minus 6 over x squared. So again, division tells me the first thing I need to do is turn that to multiplication and flip this. So when I rewrite this one down here, what can I do instead of writing x minus 6 squared? Can't I write x minus 6, x minus 6? Sure, why not? It's the same thing. X minus 6, x minus 6. What's that denominator? 8x. I change division to multiplication. I put the x squared on top now and the x minus 6 in the bottom. So again, I'll go anywhere where there's more than one term to see if I need to do any factoring. Let's see, that's already factored. I can't do it, that's only one term. That's only one term. But this is 2 terms. But I can't do any factoring there, right? There's nothing in common with x and 6, and it's not a difference of squares, which is the only 2 things I'm looking for if I just have 2 terms. So, but I do notice what happens. This x minus 6 will cancel either one of these, just not both of them. So now that I've canceled my parentheses, let's write what is left. I have an x minus 6 and an x squared in the top. So let's see, x minus 6, x squared, which means I can write that x squared either behind it or in front of it. It doesn't matter. It's multiplication. It doesn't matter what order it's written in. I'm going to put it in front because I just like to see my parentheses in the back. In the denominator, I have 8x times just a 1. So all I'm left with is this 8x. Now, look what you have. You've got an x squared in the top and an x in the bottom that are factors, right? Everything's multiplied. So let's see. If I subtract my exponents, I'll be left with x to the first in the top. So let's see, what are you left with after you cancel those x's? You have an x and x minus 6 left in the top. And what do you have left in the bottom? Just the 8. Okay? Number 8. So another 8 is multiplication. Remember, that's the first thing you're going to have to check for. Is this multiplication or is this division? So number 8 says to multiply, you've got 7x minus 21 over 5x plus 15 times 6x plus 18 over 10x minus 30. Okay, remember, you can't start doing any canceling or anything like that until you've gone to all 4 spots to see if there's any factoring to do. All 4 spots have 2 terms, which means there's a chance to factor all 4 spots. So let's look at the first spot. 2 terms. What goes into 7 and 21? So what I'm going to do on this second step is I'm just going to rewrite all of this, but in its factored form. So let's see. Up here, since 7 goes into both of these, I can pull out a 7, put in parentheses what is left. So let's see, if I pull out a 7 and divide those both by 7, what is left here would just be an x minus 21 over 7 is 3. So done with that one. Look at this one. What goes into 5 and 15? 5 does. So I'll pull out the 5, put in parentheses what is left. So if I divide these both by 5, put in parentheses what is left. Here I'll have an x, this time plus 15 divided by 5 is 3. Now, second fraction in the top. What's the biggest number that goes into 6 and 18? 6 will, right? You want to always pull out the biggest. So 6 will go into both of those. Put in parentheses what is left. So if I divide these both by that 6 that I just pulled out, the 6's will cancel here. I'll just have that x plus 18 over 6 gives me 3. And the last one, what is the biggest number that goes into 10 and 30? 10 will go into both of those. So if you pull out the 10, put in parentheses what is left. So let's see, dividing those by that 10 that I pulled out. So if I pulled out the 10, all that's left here is an x, this time minus 30 over 10 gives me 3. So let's see here, now I've got parentheses all over the place. Let's see if any of them cancel to make our life more simple, right? If I get rid of stuff, I don't have to see it all. Let's see, is there an x minus 3 in the bottom that will take this one out? There is, right there. So that x minus 3 cancels that one and turns it into a 1. Let's see, I've got an x plus 3 in the top. Is there 1 in the bottom? There is. So this x plus 3, we'll take this one out and turn it into a 1. I don't have any more parentheses left. So let's just go ahead and multiply straight across in the top and straight across in the bottom. So up top, I have 7 times 6, which is 42, over 5 times 10, which is 50. Math, enter your fraction. So let's see, 42 divided by 50 gives me 0.84. So let's math, enter that. What does that give you? 21 over 25. So 21 over 25 is all you're left with after that whole problem because so much parentheses canceled for you. Now, before we do number 9, let's look at what happens when things cancel. What's really happening is this x plus 3 over itself turns into 1 over 1, right? Because if you have something that's exactly the same in the top and the bottom, it's equal to 1. Let's look at some other things that are equal to 1 and then take it from there to see what would make something equal to -1. So let's see, 10 over 10 equals 1, right? Anything over itself. -17 over -17. If it's exactly the same in the top and bottom, it is 1. Let's see, AB over AB, exactly the same in the top and bottom, it's 1. What we were dealing with in these last problems, x plus 3 over x plus 3. Is it the same in top and bottom? It is. That's 1. But let's see. what equals this? Or what does this equal? Let's say you have -5 over +5. -5 over 5 is -1 over 1, which is -1, right? So let's see, I have, so let's see, -AB over AB, that will reduce to -1 over 1, which is -1. What about this? Let's talk about this. Or actually, let's write it like this. X minus 3 over 3 minus x. What is your x in the top? It's positive. What is your x in the bottom? It's negative. What is your 3 in the top? It's negative. What is your 3 in the bottom? It's positive, which means the top is the exact opposite of the bottom. This right here cancels out and makes a -1 over 1, which makes it -1. So again, the top and the bottom are opposites. That makes a -1 over 1. So let's keep that in mind on problems like number 9. I've got 8 minus j over 4 divided by j minus 8 over 10. First of all, it's division, which means my first step is to rewrite and flip the second fraction. So I've got 8 minus j over 4 times 10 over j minus 8. So what I want to concentrate on is I'm looking at these two spots right here. I'm thinking they're either going to cancel and make a 1 or cancel and make a -1. So let's see what's happening here. What is the 8 in the top? It's positive. The 8 in the bottom is negative. So they're opposite. What about the j? Negative over positive. So they are opposite. So this 8 minus j over j minus 8 cancels and makes a -1 over 1. So when I multiply, I have -1 times 10, which gives me -10. Over 4 times 1 is 4. And then that is what you are going to math enter in your calculator. So -10 divided by 4. There's your decimal math. Enter it to get -5 over 2. All right. Best for last. If you are at the bottom of a sheet of paper and you want this problem to all fit on one sheet of paper, you need to start on a new side of paper. I'm going to pause it for just a second. Okay, the last one. Again, make some room. We've got 8r squared minus 79r plus 63 over 8r squared plus 57r minus 56 times 9r squared plus 65r minus 56 over 72r squared minus 119r plus 49. This problem is a nightmare because all 4 spots are trinomials, and they're the long kind. So here's how I'm going to organize this work. So what needs to occur is all of these need to be rewritten in their factored form, which means I'm going to rewrite these fractions, and they're going to be in their factored form. So everything that's going to be factored is going to end up being in its two parentheses, right? That's what it looks like after you do that long kind of factoring. So since I'm limited on my area to work, I'm going to do, it's like 4 problems in one. So this one, I'm going to do the long kind of factoring right here. And when I'm done and get my 2 parentheses, I'm going to put the answer there. And then I'll start over with the second one. So remember, this is going to take a lot of work. So let's see. What is the long type of factoring say to do? I'm going to do 8 times positive 63. I'm not going to do any of this work in my head. So 8 times 63 gives me 504, and it's positive. So I'm going to make my T-chart. And remember, this is the number that goes in your y equals. So go to your y equals and clear everything out. Put in 504. And then remember what you're going to put in. Divided by x. Then go down 1 and do the same thing. 504 divided by x. And then what are you going to put after that? Plus x. So what I want to do is find all the numbers that multiply to 504 and add to negative 79. So this is the number you are looking for in your last column of your table. So remember how to get there. You're going to hit second and then hit this table button. Here's where you're looking. The last column, I am looking for negative 79. So it looks like it's getting closer going this way, right? We're almost there at negative 90. So let's just go up some more. There it is. Which means here's the 2 numbers that you are going to use in your T-chart. They multiply to positive 504. If you multiply those 2 numbers together, you get 504. If you add negative 7 to negative 72, you get negative 79. So those are the numbers I'm going to use. A negative 7, negative 72. Again, remember, just follow the steps. You can use your calculator for all this work. What is the net? What do I need to put these both over? 8R. Reduce your fractions. So again, you're just math entering both of those. So let's see, negative 7 over 8. So get back to your home screen by hitting second, quit. And if you want to clear it out, clear it out. So what I say, negative 7 divided by 8. Enter, then math, enter that, negative 7/8, which means this one doesn't change. What about this one? Negative 72 divided by 8. So negative 72 divided by 8 tells me I do need to reduce that to negative 9. So look what happens here. This negative 72 over 8 turns into negative 9. So that's where your answer is going to come from. Bottom, then top. So what's in the bottom of this first fraction? 8R. Then your top. Include the sign. -7. Now, since this canceled, what's left in the bottom? Just that R. And what's left in the top? Include the sign. -9. So again, where did I say I was going to put that answer? That is this first top of this first fraction in its factored form. So 8R minus 7, R minus 9. So now let's do the bottom of this fraction. So again, I'm going to just erase this work. I'm going to do it all over again. And where is this one in factored form going to go? In its spot. So I just need to find out what goes in those parentheses the same way I just did the last one. Be careful with your signs. I've got 8 times -56. So 8 times, remember where your negative is, it's below the 3. -56 gives me -448. Again, it's a big number, but we're just going to make our calculator do all this work. So -448 is what's going where? In your y equals. So go there, clear out your last problem. So clear, go down, clear, go back up. So I'm putting in, again, -448. So don't forget your negative. 448 divided by, then hit your X button, this one right here. Then go down and do the same thing. -448, do divided by X, and then remember you're going to throw in a plus X. Go to your table. Second table, what are you going to look for in this very last column? What's the middle term? It's positive 57. So let's, oh, how did I get that lucky? It's my very top one right there. If you need to scroll up and down to find it, remember you're looking for positive 57. Once I get it, you're using these numbers, oops, in your T-chart, right? Positive 64, -7. So positive 64, -7. What's the denominator going to be? 8R. Math, enter your fractions. So let's see. Second, quit to go back to your home screen. My first fraction is 64 divided by 8. So that'll cancel and just make it 8. So positive 8. When you put this one in, -7 divided by 8, math, enter it, nothing changes, which means it's exactly what it needs to be. Now, be careful here. This 8 in the denominator is gone, right? The only thing that's left down here is that R. Up top is your plus 8. Down here, 8R. Up top, -7. So where did that come from? This one right here. Comes right here. So R plus 8, 8R minus 7. Do it again. Now, where am I going? The top of the second one. I'm going to do it and put its parentheses right here. So let's see, my outside, 9 times -56. So 9 times -56 gives me -504. That's what goes in your calculator. Where does it go? Y equals, just change your top to -504 divided by X, and your bottom to -504 divided by X plus X. Second table, what are you looking for in your last column? What's my middle number this time? I'm looking for positive 65. So it looks like I need, oh, there it is right there. 65. I'm getting lucky. So I'm going to use 72 and negative 7. So positive 72, negative 7. What am I putting them over? 9R. So let's see, 72 divided by 9 gives me positive 8. That 9's gone. Negative 7 divided by 9. If I do that and math enter it, it's still going to give me negative 7 over 9. So it doesn't reduce. So let's see. In the bottom, I've got R. Up top, plus 8. In the bottom here, 9R. In the top with its sign, minus 7. So where does this go? That was the top of the second fraction, right? So let's put it in the top of the second fraction. I've got R plus 8. And I've got 9R minus 7. And I've got one more spot to fill. This bottom one. So I'm going to do the same thing. This is a great practice problem for this kind of factoring. Ooh, this looks like a horrible number. So multiply those outsides. I've got 72 times positive 49, which gives me 3528 positive. That's what I put in my y equals. So go to your y equals and clear it back out. $35.28 divided by x. $35.28 divided by x. And $35.28 again divided by, there's your x button. And then throw in the plus x button. Second table. What am I looking for in that last column? Negative 119. So let's see. It looks like I need to go up, right? I need to make these negatives number get smaller. So I need to go, so get in, there's negative 401 decimals. I'm trying to get this column to say negative 119. Oh, negative in the 100s, negative 166. Getting closer. Negative 134, getting closer. This takes a second, but it's a lot easier than trying to do it on your own. I'm getting close, negative 121. There's negative 119. So what am I using? Negative 56 and negative 63 in my T-chart. Negative 56, negative 63. What do I put those both over? I'm going to put those both over. Yuck, 72R. But remember, I've got my math enter button to do this work for me. So let's see, my first fraction, I have negative, so back to my home screen. So negative 56 divided by, my denominator is 72. Enter, math, enter. So that's going to reduce to negative 7 over 9. So negative 7 over 9. Or 9R, I guess you can leave it, 9R. Now do the other one, negative 63 divided by 72, then math, enter that to get negative 7 over 8. So let's see. What's the first parentheses? 9R. What's up top with the sign now? Minus 7 in the bottom. I just have R, or excuse me, 8R, sorry, up top minus 7. So this is that very last one. So 9R minus 7 and 8R minus 7. So there's pretty much all the work. Now what are you doing? You're looking for any parenthesis or factor in the top that can cancel one in the bottom. Let's see, do I have an 8R minus 7 to take this one out? I do, right here. Okay, it can just take out one of them, not both of them. So this 8R minus 7 takes that one out. Let's see, is there an R minus 9 to take this one out? No, so that stays. What about an R plus 8 to take this one out? Here's one. So the R plus 8s are gone. What's my last thing? 9R minus 7. There is one in the bottom, so that takes that out. So what is left in the top? The only one left in the top is the R minus 9. What's left in the bottom? 8R minus 7 is your answer. R minus 9 over 8R minus 7. Now, I'm going to stop this video, but I'm also going to make the video for 7.3. I just want them to be 2 separate videos. So I'm going to stop this one and then start one for 7.3.